I'm going to go through this week one overview document. And if you go to your modules, what you have is Professor Toper's course. And I'm going to add whatever I put on top of it, I'll put under this independent study notes. This will also be where I put links to the recordings of meetups. The only other thing I've done, at least so far, is on the assignments. If you go to the assignments, they now have new dates for them. I'm not going to grade the live sessions, just give you credit if you show up, and if you don't and have an excuse, you'll get credit too. But generally, you're supposed to be here. But everything else now has new due dates based on his schedule. So if they're not sequential, it's because in a couple places he decided he decided to move his module 11 practical challenge to after module 10 and 13. So I did the same. But I generally have kept his course as is with just revised due dates. And it is an aggressive amount of work. So back to my add-on material. In his assignments, he says he wants you to do 5-minute recordings each week. I want you to come to the meetup ready to present your work, okay? If you can't present your work in meetup, I'd like you to record it and submit it to me ahead of time. As a tip, if how many of you want to be able to one day present as well as Wang Yu Chen? So everybody, good. One way to be able to present better is to actually make a recording before, just to practice for yourself. So I encourage you to do recordings if you like, but where Professor Toper says record and submit, I want you to submit and come to class ready to present. Okay? Does that work for everybody? I also will tell you that having good presentation skills opens a lot of doors for you, not just Xianxin, but everyone else who wants a job. Did I tell you, how many of you have had to listen to my story about my colleague, Joe Tsai? I think, you know, I only have so many stories. Let me tell you about Joe Tsai. So he's from Guangdong, you know, which, you know, that makes him a pirate. He's from a southern province of China where everyone is somewhat criminal. Did I say that right? I mean, they're entrepreneurial. It's a very entrepreneurial. It's like Andhra Pradesh, you know, high literacy, very ambitious. Ashwarya, which province are you from? Which state in India are you from?
Maharashtra.
Oh, okay. Is that,
Yeah.
That's in South India?
No, in West. Yeah.
Okay.
Yeah. You must know Bombay, Mumbai.
Oh, okay.
Yeah.
Understood. Thank you. So Joe worked for me, and when my company, our biggest customer was an investment bank called Donaldson Lufkin Genret. And they were acquired by another bank, Credit Suisse First Boston. So after they were acquired, I was kind of scared for the future of my company there because they were our biggest customer and they'd been bought by somebody else. So the new company asked us to bid on a project. It was a big project, and it would require 10 or 11 people. So, you know, they said it's very time compressed. So I brought in my whole team to hear the presentation, right? And the new boss of my boss was there, and his boss was there, and they explained what they wanted in general, like in business terms. And they said to me, we want to hear your team's approach, right? And so I walk up to the whiteboard to present, and the guy said, no, not from you. I want to pick one of your team members. And they picked Joe Tsai. And Joe is, he's very small, like a lot of people from the South, right? He's about 4'10", and he is I think they picked him probably because they thought he was Chinese and didn't speak English very well. And I hired Joe because he was an extremely good and productive programmer, right? And he spoke English well, but mostly all I ever heard him do was swear in English. You know, he talked like a sailor. He used one four-letter word after another. So I was a little nervous when he went up, and the future of my company is at stake, to the whiteboard to explain our company's approach, right? Joe goes up to the whiteboard in 5 minutes, gives a better presentation than I could have, and, you know, nods his head, walks back to the back of the room, and sulks back in his seat. And we got the job. So I said to Joe, how did you do that? And I won't swear, I'll just say silly, and where Joe was putting in some really colorful and bad words. And Joe said to me, do you remember that place I used to work, the oil company? You know, those silly guys that I worked for, whenever I had an idea, they made me present it, and they yelled at me, and they made me present it again, and they yelled at me. So everything I did, I had to present 8 or 10 times for years. And he'd gotten really good at it, right? Which I'd never seen, because all I saw was Joe like building things really quickly. So the way you get better at presenting is to present a lot and get feedback, right? That's why I want to ask you to present each week in class. And the less that you want to present, the more benefit you'll get from doing it. Does that sound reasonable to everybody? So, okay. Let's see, a few other small things. Professor Toper has a timed midterm and final that you had 2 hours to do in 24 hours. I'm going to make it 2 hours to do honor system in an 8-day period. Okay. So same thing, but you just, you know, you can fit it in around the rest of your schedule a little better. Later in the course, he has you doing some with TensorFlow and Keras. You're welcome to do it with that, but you can also use PyTorch and or FastAI if you prefer instead. He says you can work together on any assignment, but the first one, my view is you can work together on any assignment. But if I feel like a student isn't like actively working on the assignment, I may require them to work independently. Okay, so if you're working together, contribute. Being able to play well with others is a really good thing. Like if you're working in groups, I want to write good letters of recommendation for everybody, but I can write a great letter of recommendation if I know that you work well in groups, because being able to play well with others is really critical to success. And if you're not comfortable working in groups, this is a great class to get comfortable doing it, because it's a small group. Everyone in the group is highly motivated. I mean, you know, these are, frankly, you're really probably the best, but you're some of the best students in the program. So, you know, being able to work with people who are very motivated can be a lot of fun. If you're a group leader and you're just trying to get the other people to show up for meetings, that's no fun. So, you know, I have some ideas for other ways we could go with the course. I plan to just teach it like Professor Toper taught it, or give you assignments like it. But if you guys decide you want to do different things, you know, propose it. I'm up for making modifications to the course. Also on assignments, if you want to do an alternate assignment, different data set, especially a different data set, I'm fine with that, but let me know ahead of time. For example, the first assignment, which is due this Sunday from Module 2, is to do cross-fold validation on regression. And if you want to use Professor Toper's flights data set with weather data instead, you're welcome to do that, or something else. The terminology in this course can be different. those of you who are taking the fast AI experience, you hear about train, validation, and test. In this course and in statistics courses, it's often train, test, and validation, but the concepts are the same. Okay? And very often in our field, the statisticians use one set of terminology, the machine learning people use a different set, and you really need to learn both sets. Most of you are also taking computational math and statistics this semester from Professor Schulte. And he will use different language and tell you things that are different than I tell you. And Mike and I have worked together for over 20 years and done some pretty good things together. I have tremendous respect for him. So if you read this paper, Statistical Modeling the Two Cultures, which was written by Leo Brayman, who, among other things, invented random forest. So he's a heavyweight in the industry. But he talks about how data science came out of the statistics program and the computer science program on campus, but the professors in the two programs don't really talk to or even like each other. So it's sort of, data science comes from these two parents, both of which are really important, but the terminology tends to be different. And you just need to learn both and kind of roll with the punches. You've probably already seen that somewhat, but you should get as much as you can out of both courses, but assume there's going to be some contradictions along the way. That is just the nature of what data science is. And of course, if you ask Professor Schulte, who's more articulate than me, he'll just simplify it as I'm right and Andy's wrong, but that's okay too. For those of you doing the Fast AI course, I think the two together will help amplify your understanding of the concepts. If you're not doing that, or you decide to drop out of it because your other classes, the workload is high enough, understand that this class is being taught independently of that. There's no overlap other than the fact you're invited to do Fast AI projects. Okay, so in the slide decks, in the Jupyter notebooks that Professor Toper's done for Module 1 and Module 2, he gives his take on machine learning. I wanted to talk about machine learning and how it fits in the data science lifecycle, which he does in his Module 1 notes. My view of it is from Vishal Patel, gives this really fun presentation he gave to a group of suburban DC data scientists a few years ago. And it's fun to go through, I think, how to become a data scientist. Good advice here. But his view of what we do is here. And you go from business understanding to data preparation, data munging, model train, model evaluation, model deployment, model tracking. In your analytics programming course, arguably, it was a lot about steps 2 and 3. Would you all agree with that? And you did a linear regression, logistic regression model, which was step 4. And for those of you who did the UT Austin, you probably did all 7 steps and could teach this course. So the rest of the slide deck, I would encourage you to go through, because it talks at still a high level of detail about how the pieces fit together for business understanding, for data preparation, and on and on. So I think this is a good deck to go through. Unfortunately, I haven't been able to find a recording of that meetup. Here's another presentation at what was called the NIPS conference. It's now called the NeuroIPS conference, which is, I think, the most important conference in the world on machine learning and AI. That's arguable. This shows how building a model fits in terms of the whole effort. And this course is really going to be focused on this black box and some other things around it. But please understand that building a model is not everything, right? In fact, could anybody describe something that's kind of major and is missing from this real world ML systems? Does anybody see anything else that probably should be included?
Maybe data cleaning.
Okay, good. Data cleaning. I think that here they would call that under feature extraction, data verification, but data cleaning is definitely important. What I was thinking was, and if you go to the Vishal Patel, you'll see data cleaning is mentioned. Like he has a different description, but getting the business requirements, the reason for doing it, which is huge and maybe out here, isn't even included in this model. So, from the perspective of the CEO or CIO, this would be an even smaller piece of the whole. And I believe, and a lot of other people believe, including Jeremy Howard and Andrew Ng, who's been called the godfather of AI, and has worked at Stanford and Google and Alibaba, and is not the dumbest person in the room. But they both believe, as I believe, or maybe I believe as they believe, that because of things like automated machine learning and transfer learning, that model building is less important than it's been in the past. It still matters a great, great deal, right? It's like it's still necessary, but it's no longer sufficient. So we are going to focus on building models, but I just want you to, understand that thinking about building your models in the context of not just the statistics and explainability and cost and et cetera, but also in terms of the whole environment, how it helps the business, et cetera, really does matter. And David Sweet, who is a professor here and only teaches occasionally. He's teaching in the summer. He's going to teach a course on experimental optimization and A/B testing. David's background is he was a PhD in physics, worked at some place I've never been to called Instagram as a data scientist. I understand that's a place to go. Instagram. Anybody ever heard of that? Yeah. Okay. And then he's gone and done high frequency trading, which is really easy, of course, which is why, all the people who do it are physicists. But he's a really amazing guy. I think he's a very good teacher. I wouldn't say he's a great teacher like Topper, but his class this summer doing A/B testing from a statistically and mathematically rigorous standpoint is a really extremely practical course. Xiangxin for you. I think that course will also help you a great deal in your pursuit of getting the best job in the world. Okay, but it's not an easy course. The reason I have David here is David said to me that in 2013, that if you could build models, if you could do what we're going to learn in this course, you would be a data scientist rock star. So if you could invent a time machine at the end of this course, you could be like one of the best data scientists in the world just going through this course, because things like scikit-learn weren't available back then, right? So said, a few years after that, maybe 5 years later, you had to be able to do the data modeling, but you also had to know how to deploy it. Said in 2023, you still need to build the models, you still need to know how to deploy them, but additionally, you need to know how your work as a data scientist or data analyst building models contributes to business objectives, right? If you're not driving the business objectives, then you're not going to be a highly sought after data scientist. Now, it sounds like they're just piling on more and more and more work here, but the data modeling part is much easier than it was in 2013. At least the 2013 level. It's gone off in 1,000 directions, but for the same amount of work, you can do a lot more. And where I'm coming from is just to say that as you're doing this, be curious about the business, be curious about what it means to take it and put it into production, et cetera, et cetera. Okay? All right. Here's Andrew Ng's talk on why data-centric is much more important than it used to be. Does anybody want to jump in? Like you're allowed to argue with me. Wang Yu Chen always argues with me. He's polite about it, but he's like, here's why I'm right and you're wrong, Andy. Go ahead, Wang Yu Chen.
Oh, I mean, I'm good. I don't want to argue with you. I agree with you.
Okay. So what's the difference between machine learning and rules-based learning?
In machine learning, we are trying to train the machine, but whereas in the rule-based learning, we are already giving the rules. We are already providing the rules, and later we are getting the answers for it.
Yes, yes. So we're learning from the data, and once we have those rules, so if this is model A and this is model B, once we have those rules, then we give it new data and we feed it into our machine learning model and get answers. So we actually, if this is 1 and this is 2, 2 actually has 1 after it. These rules plus data into the model gives us new answers, right? Yeah.
Yeah, Professor, can you give me a very detailed example of this rule-based learning, because I didn't know this concept before?
Yes. Xiang Shen, have you ever heard of something called spam?
Spammer?
Spam. Do you know what spam is?
No. Sorry.
Okay. So have you ever gone to your junk mail folder? And in your junk mail is mail that's been, incoming mail that's been identified as potential spam. It's mail that they think you didn't want to read. Okay?
Okay.
So 25 years ago, to people who wrote spam filters, if someone was trying to identify incoming email as spam, they would do things like saying, if more than 3% of the characters are exclamation marks, or the word Nigerian prince appears, or half of things are in uppercase, then it's spam. So there were a set of rules. And it might say that, if it's the amount of percent signs might be 10% likelihood of spam, Nigerian prince would be 15 points. And if it's above 50 points, it could be a complex set of rules. But the way they did things back then was rules-based programming. And this was difficult for spam, but it was almost impossible for things like image files, audio, natural language processing. Well, I guess that is a natural language processing example. So, translation then back then was, if the word was smart, say 聪明, or in Cantonese, the word for smart is 万有真, right? But that would be a rules-based system, whereas in a machine learning system, you take a huge amount of data, or as much quality data as you can get, and train your model from that. Okay. Does that help as a rules-based versus?
Yeah, our understanding is that machine learning helped you to find the rules, right? And the rules, you can use the rule-based learning to do something like the function, and you can sort of filter something based on the rules.
Yeah, Yeah. So let's talk about linear regression, right? Does anybody know the formula for one variable linear regression?
Y equal to A times X plus B.
Okay, so y equals ax plus b or mx plus b. And what we have there, you could say that, for a temperature conversion from Fahrenheit to Celsius, you could say y equals mx plus b deterministically, right? You could also take a rule that, the delay on an airline could be the wind speed could be 5 minutes plus the wind speed times 0.2, right? You could make up a rule. You could generate the rule statistically. You could generate the rule from linear algebra or calculus, right?
Yeah.
Because linear regression can be done from calculus, from algebra, from linear algebra. But you can also do it by taking a lot of labeled data and finding what weights work well for A and B, or M and B, and adjusting them using something like gradient descent. And that method is machine learning, and it has some advantages over the others. First of all, the calculus and the linear algebra forms for regression don't really work if you have millions of rows of data, right? What you learn in a calculus or statistics class is analytical closed form solutions. But with machine learning, you use tools like partial derivatives and gradient descent that allow you to work with immense amounts of data. It's also, on a spam model, instead of saying y equals mx plus b, when we say y equals mx plus b, what is the feature? Y equals y, m, x, or b. What is the feature?
X.
X is the feature. And it could be one column or it could be 1,000 columns, right? What is y? Y is the
labels, dependent variable.
Yeah, it's the label, or some people say target. Some people say dependent variable. Schulte probably says dependent variable, right? They're all the same thing. And instead of y equals mx plus b, you could have 10 or 100 variables, or 10 or 100 weights instead of m and b. And in fact, large language models like GPT-3, how many weights do they have? If single linear regression has 2, GPT-3 has about how many? Take a guess. Look it up. Somebody go look it up. How many weights does GPT-3 have?
Just a guess. 3 billion.
3 billion. Okay. I think that's a good guess. Does anybody find it online? I think
96 layers, and
96 layers. I think it's something like 60 billion.
175 billion.
75 billion. Okay.
175, yeah.
175. Okay. Does that seem like a lot compared to 2? Okay. So the next one that's coming out is called GPT-4. Can anyone find how many weights that's expected to have?
100 trillion.
100 trillion.
Yes.
Yeah. So let's see, 2 and 100 trillion. Wang Yuchen, you're like a very smart guy. Which is bigger, 2 or about 100 trillion?
Of course, not two.
Okay, thank you, sir. See, I always go to Wang Yu Chen when it's a really hard question. And, you know, when you start getting lots of data, and, you know, those are examples of like really lots of data, right? But things like spam become solved problems. You know, things like autonomous driving become possible. And in order to do that, you need to have machine learning and some pretty advanced machine learning to do things, and often a lot of compute hardware, et cetera, et cetera. But it really, you know, the rules are the weights. I mean, that's a little bit of a simplified view of it, but you could say that getting the weights as close to right as possible is setting the rules. Okay. And what's the difference between machine learning and statistical learning? I'll let you read Breeman's article. Actually, because we're at 20 to 12, I want to push on a little bit here. Okay, how many of you play chess? Nobody. Okay. Does anybody know what the names of the chess pieces? Nobody? We'll skip this example then. All right. Predicting flight delays from weather conditions. So if you are given weather data, and this is your Module 2 assignment that's due Sunday, but I'm inviting you, if you want, you could use weather data to predict flight delays instead. And Professor Topper in the Module 1 notebook talks about flight delays, and I've got 4 data sets here that you could download if you want. But if you wanted to predict flight delays from weather conditions, who would care about that? Who might care?
I think
Customers?
passengers.
Yeah.
I'm sorry? Who?
Passengers.
Passengers, yeah. Okay, so if I'm a passenger and I know that Atlanta's airport is always bad, and I'm booking a flight through Atlanta, I may need to make sure that I have at least an hour of layover time, right? Or if I know this airline takes me 2 hours longer than it's supposed to get to Mumbai, then I might take a different airline instead, right? And a passenger probably cares about actual arrival time versus scheduled arrival time. But an airline probably cares about scheduled departure time versus actual departure time. And that's in part because at the end of every year, the Wall Street Journal does this big analysis of airline quality. And one of the big factors is which airlines have the most delays, and they do it based on departure time. Okay? So knowing the audience for your analysis may drive which variables you use in your analysis. So understanding who's going to use it, how they're going to use it. The definition of a flight delay, you might say, okay, if the flight delay is, we could say, if the actual departure time is after the scheduled departure time, it's a delayed flight, right? That would make sense. But the FAA says if it's more than 15 minutes late, then that's a delayed flight. So again, having some domain knowledge really does matter, okay? In your first assignment, you're asked to do cross-validation. And I think Professor Toper has a lot of good material on that. And if you go through that and you try the assignment and you reach out to me before Friday, because if you reach out to me Sunday afternoon, I'm going to assume you're not serious about the assignment if you're not looking at it till then. But if you get stuck, you can partner with somebody else. You can reach out to me for help. But in addition to the resources he gives, there's 10 pages in this book that are very good. Additionally, there's videos to go with it. The examples are in R instead of Python, but it's mostly the concepts of cross-validation. For those of you who are doing the Fast AI, here's an advanced talk on cross-validation with Fast AI. It's pretty far beyond where we are in the course right now, but for those of you who are interested, it's actually not done by Jeremy Howard, but by a student of his who was probably the most active on the forums. Some additional reading. For next week, I want everyone to present their assignments, but also if a student wants to give a talk next week, and I want everybody to give at least one talk, but here would be a talk you could give next week on the difference between bias variance trade-off and underfitting, overfitting. Has anyone here ever taken a data science course at UT Austin? Okay, so Wang Yu Chen, what does K and N stand for?
It stands for K nearest neighbor.
Good. And this top drawing is K nearest neighbor based on 10 nearest neighbors. This is based on 1, and this is based on 100. And it creates 3 different decision boundaries based on 3 different settings of the hyperparameter. And we'll talk about K nearest neighbors later in the course, for those of you who haven't been to Austin. But one of these represents underfitting, one represents overfitting, and one is probably pretty close to good. Can anyone tell me which one of these is overfit and why?
The left one is overfit because it
You're saying K equals 1 is overfit.
yeah
Yes. Why?
because it's too special because we need more casual model. I don't know if I speak it right.
Well, you're right. It's too specialized. Or to put it another way, it would not generalize well to new data.
Yeah,
Right?
yeah.
All right. So which one is underfit?
Right one.
Yes, the right one is underfit
Yeah.
because it's not complex enough. It's too simple and it doesn't capture the nuance of the data as well. And so there's trade-offs between underfitting and overfitting, and arguably K equals 10 is the best of the 3. Because your goal isn't on your training data, but to get the best fit on your holdout data or your test data, depending on whose terminology you're using, right? So does anyone want to volunteer now to read the paper that I provided and do whatever other research they could and do a 5-minute talk on the relationship between bias and variance and underfitting and overfitting for next week? First person to raise their hand, you get an extra credit point, whatever that means. All right, Liu Deng Yi, yay. Okay, and everyone will have a chance to do this once during the semester. So for next week, for Sunday, I want everybody to please go through modules 0, 1, and 2 to, in particular, look at Professor Toper's notebooks and to do the assignment for module 2 and the discussion items for module 2, okay? If you've got to cut corners on the discussion items, And if you get the assignment half done, that's still good, right? Turn in what you can do. Start early, work with teammates. Do you guys want me to set up a Slack channel for the course? Would anyone benefit from a Slack channel? All right, I got a couple of heads. I'll set up a Slack channel. Okay, so we're at 11:48. Any questions, comments, anything people want to talk about?
Yeah, Professor, one thing I want to make sure is that, so next week we will present our assignment. So do we need to, take a record of our presentation before the?
No, you do not. You don't need to
Oh.
record it as long as you're presenting in class.
Gotcha, thank
You
you.
may benefit out of recording it, and you're welcome to. And if you think you can't be here Monday, I'd very much like you to record it, okay? Also, as you know from Professor Toper's analytics programming course, he will give an example that helps a lot with the assignment. Not everything you need, but a lot. So make sure and go through his Module 2 notebook where he'll give an example that will be very helpful in the assignment, okay? And if you don't find that helpful enough, reach out to me. Also, this course book has a lot on things for the assignment, right? I mean, you can find things online, but this is a really excellent book, and I recommend it. It's technically a required book, but you'll find a lot of material that's helpful on the assignment. All right. What else would you like to do today?
Question.
Ashwarya?
Yes, I have a question.
Yes, ma'am.
Is there any chance that we can get any small projects from any organization just to get hands-on? So instead of doing the assignments, we can do small projects on data science related to our course.
I can look for those. And Ashwarya, several of you are going to be GAs for me, including you, Ashwarya. I think you've been,
Okay.
I think Professor Toper wants you to be his grader. I don't know if you want to do that or you want to just do
No.
research, but he's specifically asked for you to be his grader. You're very popular among the teachers, but he also made a list of people who want to be his grader, and I can say that a number of other people in the room also made his short list. Actually, most of you. There are a number of projects that people have asked me about. One of the challenges I have, Ashwarya, is that all of those projects right now require some natural language processing. And
Okay.
I'll put together a list and you can look them over. And in fact, I think I've said this to you, part of my motivation of doing the Fast AI experience is to try and get some people with some NLP skills for summer research projects. But if you want to try and fast track that, we could definitely do that. So for example, in the Fast AI course, I think you'll be doing NLP in a couple weeks. And let's see. AWS SageMaker Studio. What's the most important data science company in 2023? What do you think?
Tesla?
Tesla? Okay, yeah, it could be. I don't know if there's a right answer. So you've all used Google Colab, right? Everyone's used Google Colab, and many of you have used Kaggle notebooks, things like that. Another tool that's also free is Studio Lab from SageMaker, and it is, you have to apply for it, and it takes a while. Like Google Colab, if they catch you doing Bitcoin mining on it, you'll never ever get to use it again. So please don't use it for Bitcoin mining unless you don't care if you never get to use it again. But what I wanted to show you with SageMaker Studio Lab, it takes a minute or two to spin up the runtime. I think this is even better than Google Colab, but less well integrated with Kaggle.